Welcome to Trigonometry 4, Bearings, and this topic is topic number 36 in Richard James Mathematics Resources. By the sound of the word bearings, I can hear some students saying that this is overbearing and some crying out to the Lord for help. Well, I'm not going to take the place of the Lord, but I'm going to see how I can help you in understanding this topic. While continuing with trigonometry, the popular saying can be borne in mind: there is nothing new under the sun. The more things change, the more they remain the same. This is just more of the same old, same old. This is because, as far as the principles that are to be applied are concerned, there is nothing new in this topic. In this topic, Pythagoras Theorem, the three trig ratios, the Sine Rule and the Cosine Rule will be applied to different and probably unfamiliar circumstances. Just the same as when a new environment is entered, one needs to know how they do things around there. All we need to do is determine how to operate while dealing with bearings. Just another environment. Just try to find out how we do things around here, and that's all there is to it. As soon as we have determined these, we may go on to solve problems without much hassle. The jargon of bearings. A bearing is expressed by using 3 digits. So that is one thing. We have to use 3 digits when expressing bearings. The bearings are measured in a clockwise direction beginning at north. So we're going to begin at north and we are going to go in a clockwise direction if the angle that we are dealing with is a bearing. Bearings have 4 main directions. Of course, no problem with that one. North and its associated angle is 0, 0, 0 degree. East and its associated angle 0, 90 degrees. South 180 degrees. West 270 degrees. It is even shocking for me to say that one of the greatest drawbacks in processing information that students have is understanding what they read. Well, this is somewhat a redundancy because there is really no reading without understanding. There is a worldwide decline in the ability to read, and this is sadly reflected in mathematics, where interpretation of problem is near non-existent. Here's our first problemic bearings. We get into it very quickly. So an airplane sets out from a city A and flies due north to a city B, a distance of 240 kilometers. It then flies due east to another airport C. If the bearing of C from A is 0, 37 degrees, find the distances BC and AC. So the plane is going to fly in a northward direction, and we have that. So it flies north to B, and we have that it's going north from A, and we have B. Everything is indicated. And the distance is 240 kilometers. So the distance, don't forget that we're going north, and the distance is 240 kilometers. Next, what happens? It then flies due east to another airport C. So it flies east to C. Right? If the bearing of C from A is 037 degrees, so the bearing is taken from A, the angle needs to be at A. The angle needs to be measured in a clockwise direction beginning at north. So if we are dealing with a bearing, it says that the bearing is taken from A. If it is taken from A, it means that the angle that we are talking about is at A. And do not forget that bearing goes in a clockwise direction beginning from north. So we are going to go at A and we are going to put a north there. Well, it is there already. So we are going to begin right here is A, and this line is pointing north. So the angle, which is the bearing, is required to start here and go down like that in a clockwise direction from north. So find the distance BC. So we're going to find the distances BC and AC. So we're going to start with BC. It is opposite to 37 degrees. So BC is opposite to the 37 degrees angle. Right there. If it is opposite to this, and the one that we have already, so we have this information here already. This one is adjacent. So this is opposite, this is adjacent. So we are talking about what trig ratio? Tangent trig ratio. So we are going to say BC over 240 is equal to tan 37. And when we transpose this, we get this 240 is going to be multiplied on this side. So BC is equal to 240 tan 37. Do not forget your transposition of formula. It will haunt you for the rest of your life. We will be using it over and over and over and over. I can't tell you how many over, but we're going to be using it over and over again. And when we multiply that by tan of 37 is 0.75. So we multiply that by 0.75. BC turns out to be 180 kilometers. There we're going to find AC. We need to find AC. It is the hypotenuse. AC is the hypotenuse, is the longest side of this right angle triangle that we have here. Do not forget that no alarm discovering that this is a right angle triangle. We know that if this is going up to north and then we go east, then this has to be a right angle, no problem. So AC is the hypotenuse with this one. And the one that we have there is adjacent. So which trig ratio contains adjacent and hypotenuse? Cosine. So cos 37 is equal to 240 over AC. How do we know that? Here is our 37 degrees. What is cos? Adjacent over hypotenuse. What is the adjacent? 240. And what is the hypotenuse? The one that we do not know, AC. Remember what I said just previously to solving this problem? If you take a look at the topic that we had before this, I repeated something that I've always said. If you have a problem to solve in trigonometry, if the one that you are going to find is in the denominator, of course, if it is hypotenuse, it should be in the denominator. The denominator, if it is in the denominator, to make transposition easy, it is placed on the right. If it is in the numerator, to make transposition easy, it is placed on the left. You may put it on any side. It will work out just fine. It just might take an extra step or two when you are transposing. So we transpose. AC cos 37 is equal to 240. So, of course, we are multiplying here. We are going to divide by cos 37 on the other side. And, of course, cos 37, 0.8. So AC is equal to 240 over 0.8, and that turns out to be 300 kilometers. Although this might not always be the case, the color code that is used for the hypotenuse, opposite, and adjacent in the topic on a right angle triangle is also used here. Right? And it is used all the time throughout Richard James Mathematics Resources. This is just more of the same. The solution of a right angle triangle should pose no challenge at this stage. Let us take a look at the question. Q is a port due west of a port P. R is a port due south of P. If the distance QP is 20 kilometers and the distance PR is 30 kilometers, calculate the bearing of Q from R. Well, let's put our information in a diagram step by step. So Q is a port due west of a port P. So here is Q and it is west of P. So if you're at P and you need to go to Q, you have to go west, and that's what this is saying. The next one, R is a port due south of P. So we need one that is south of P also. So R is a port south of P, and there it is. and we're going to have a distances. The distance QP is 20 kilometers, and the distance PR is 30 kilometers. Lovely. Calculate bearing of Q from R. This marked angle is not the one that the question is requesting. However, it is essential in calculating our final answer. So, of course, this is not the final answer that we want. If you calculate this angle, that will not give the answer that is required. Why? It's asked for the bearing of Q taken from R. This is R. The bearing of Q taken from R. So this is where the bearing is going to be determined, at R. However, what is bearing? Bearing is the angle that is calculated beginning at north. So this angle, notice where it begins. It begins right here and goes in that direction. Although it's going in a clockwise direction, which is required for bearing, it is not beginning at north. So that is not it. However, if you need to calculate the angle at R, which is the bearing at R, you need to make use of the angle that you have at R. So let us make use of that angle. The bearing is taken from R. The angle must therefore be at R. The known sides PQ and PR are opposite and adjacent to R, respectively. The trig ratio is therefore tan. So here we have R. This is opposite and this is adjacent. And of course we are abiding to our color code. So tan R is opposite over adjacent, and we work that out. And then, of course, if we have the tangent of the angle, then we find the angle by taking the tan inverse. So R is equal to 34 degrees. Now, our ancient color code is used because the resulting triangle is right-angled. When the triangle is not right-angled, we will have to take appropriate steps applying the sine and cosine rules. The problem requires the bearing of Q from R. The angle calculated is not a bearing because it does not begin at north. Let us therefore proceed to calculate the bearing. So this is our situation still, and we know the angle. The bearing is to be taken from R. Let us therefore place our north line at R. Yes, so we're going to put a north line at R. So that's the north line, because bearing is taken at R, and it is measured in a clockwise direction beginning at north. So that is our north line. So we need to go in a clockwise direction now. The angle must be shown to begin at north and go in a clockwise direction. So that is it. This new angle that is shown is short of a full revolution of 360 degrees by an amount that is equal to the angle R that we have calculated already. So notice that this angle will go right here and go and stop right here. And notice how this goes right there. So if you put the two of them together, you'd get 360 degrees. Therefore, what is this one? This is short of 360 degrees by the angle that is equal to R. The angle that we need, which is the bearing, is short of a full revolution by the angle R that we have found, and that angle R is 34 degrees. So the bearing is equal to 360 degrees minus 34 degrees. A fishing boat places a float on the sea at A, 50 meters due north of a buoy B. A second boat places a float at C, whose bearing from A is 150 degrees. A taut net connecting the floats is 80 meters long. Calculate the distance BC and the bearing of C from B. So let us take it step by step and make our diagram. A fishing boat places a float on the sea at A, which is 50 meters due north of a buoy B. So this statement declares that A is north of B, and this should be shown in the diagram. So A is 50 meters north of B. Bearing is measured from north. It is important to place the north line at A in order to show the bearing clearly. So the float at C has bearing of 150 degrees taken from A. So we're going to take bearing from A, so we're going to put our north line at A. And of course that bearing is 150 degrees, and it goes in a clockwise direction beginning at north. So we're going to begin at north and go in 150 degrees like that. Right, so that is it. 150 degrees beginning at north, and that is the bearing of C. And C is down here. And it says now that the taut net that connects the float is 80 meters long. So we have 80 meters, that is the net that goes from A to C, and that's 80 meters long. And we have that indicated right there. The triangle ABC is the figure that we will use to solve the problem. All of our knowns and unknowns have to be concentrated in that triangle. So we have a triangle ABC, that triangle ABC right there. Of course, we need to complete the triangle because we are working with trigonometry. So the triangle is going to be necessary. So we draw the line BC that completes the triangle. There is nothing that clearly points out that a triangle is right angled. It may be, but we cannot make such an assumption. We therefore have to solve the problem with the information given, considering that the triangle is not right angled. So what do we need to find first? Calculate the distance BC. How do we find BC? We have two sides and the triangle is not right angled. We therefore need to have an angle. So we have two sides, we need an angle, and see if we can make our calculation. So we have two sides and an angle. The 150 degrees angle cannot work because it is not inside of a triangle. So this angle that we have right here cannot be used in our calculation because it is not inside of the triangle. Based on our knowledge of angles, the internal angle at A can be easily determined. So we are going to do that by considering this straight line. So we're going to put a line right here and see what happens. So we have our line right there. The angle on that straight line is 180 degrees. The external angle is 150 degrees. Therefore, the internal angle is the difference between the two of them. So this angle here that we have on the straight line all the way like that, half of a revolution is 180 degrees. So this part alone is 150 degrees. So this one has to be 30 degrees. Let's put that there, 30 degrees. We now have two sides of a triangle and the angle that they form. Now, because of this 30 degrees that is included right here, we have two sides of a triangle and the angle that the two sides form. So we need to find the side that is opposite to the angle, which is the one down here, BC. This is therefore a candidate for the application of the first version of the cosine rule. So now we have our cosine rule. Remember, need to find a side. So we have the angle opposite to the side and the two sides that form the angle. So we need to apply the cosine rule. Take a look at the topic on cosine rule if there is a problem figuring out how we are going to use it. So we're going to calculate the distance BC. So make use of the pattern observed in the examination of the cosine rule. Remember that pattern? There we have it. So we're going to say BC squared is equal to this squared plus this squared minus 2 times this cosine of 30. And that is a pattern that we have developed when working with the cosine rule. That we need to find this side that is opposite to the angle. We have the two sides that form the angle. So we're going to say 50 squared plus 80 squared minus 2 times 50 times 80 cosine 30. Of course, we may put the 80 first. And there we have square of 80 gives 6,400 and of 50, 2,500. And then we have 2 times 80 times 50. So what we can do is say 2 times 50 is 100. So 100 times 80 is 8,000. And of course, cosine of 30 is 0.866. So we are going to add these and we get 8,900, and then we multiply this by this, we get 6,928. So BC squared is equal to this. So remember how we find BC? By taking the square root. There we have it. Taking the square root, all we get is 44 meters. And it goes right there. So that is our 44 meters that we have just found. Now we need to find something. So we need to find the bearing of C from B. What do we mean when we say the bearing of C from B? It means that we need to determine the angle that is at B that represents the bearing of C. So we are going to go right here because it is taken from B, and this is the line that goes to C. So we need to determine the bearing that is this angle there. The bearing is taken from B. The angle must therefore be at B. Bearings go in a clockwise direction beginning at north. So that's it on our diagram, showing that it goes in a clockwise direction beginning at north. The angle required fits right into the triangle and therefore need no extra special feet to find. We have the three sides and an angle of the triangle. The easier sine rule may be used. It is not good to use the sine rule to find an angle that may turn out to be close to 90 degrees. Whether the angle is greater or less than 90 degrees, the sign of the sine will be positive. That means if you have an angle, say 95 degrees, the sine of that angle is positive. If you have 85 degrees, the sine of that angle is positive. So your calculator will not give you a difference or a distinction between 85 and 95 degrees. The sign of the sine will be positive, making it impossible to distinguish between the two. So you could not distinguish between the two quite easily because, say, sine 95 and sine 85 are equal. So when you use your calculator to find sine inverse of a figure, if the angle is 85 degrees, the answer that the calculator will give is 85 degrees. If the answer is 95 degrees, the answer that the calculator will give is 85 degrees. However, if the angle is obtuse, its cosine is negative, and if it is acute, its cosine is positive. So there you have the difference. This makes it easy to determine if the angle is slightly greater or less than 90 degrees, because there's a difference between the sine of the cosine. So because of this, we choose the more sophisticated cosine rule, which is the second version that we are going to be using. Second version of the cosine rule to find the angle. And don't forget that the reason why we are doing it is because in that region close to 90 degrees, obtuse and acute angles have the same sine, but for cosine, the sign will be different. That is not the trig ratio sign, but the directed number sign is going to be different. Let us call the angle B and proceed to use the pattern developed for the second version of the cosine rule to find it. So remember how we find the cosine of an angle B? What do? Say this is the one that we are going to find. Remember, the two sides that form the angle always go together. So we have 50 squared and 44 squared. They are going together right there. And then the one that is odd, which is the one that has nothing to do with the angle, is subtracted. So we have that subtracted right here, minus 80 squared. And of course, that is over 2 times what? The two sides that form the angle will go there again. No problem whatsoever. So we are going to square, square, and square. And of course, we have 2 times 50 is 100 multiplied by 44. So that is 4,400. And that's what we have right there. So we just add these and subtract this, and we end up with negative 1,928, and that we're going to divide by 4,400. It gives negative 0.44 and That's cosine of b. To find b, we do the cos inverse. And that's 116 degrees. Now, if we use the sine rule, we would not get an obtuse angle for an answer. And of course, that would have been wrong. If the sine rule were used, the answer would have been 64 degrees. This would not be correct. If we check sine 64 and sine 116, the answers will be the same. We are sure that the answer is 116 degrees because the cosine turns out to be negative, while cos 64 is positive. This being negative, we are sure that it's 116 degrees. Now we have J and K are two pairs. Let us read the question first. J and K are two pairs. K is 25 kilometers due east of J. From a boat B due south of J, the bearing of K was 60 degrees. Find the distance BK and BJ. So we're going to find those distances BK and BJ. So we're going to be taking a look at that first. J and K are two pairs. K is 25 kilometers due east of J. So J and K are two pairs. K is 25 kilometers due east of J. J, K, and east by 25 kilometers. From a boat due south of J, so the boat is south of J, the bearing of K was 60 degrees. So the bearing is taken from the boat. So the angle that represents the bearing must be at the boat, which is B, and it must be clockwise. It must be measured in a clockwise direction, beginning at north. The bearing is taken from B. The angle needs to be measured in a clockwise direction, beginning at north. There. Good. Find the distances BK and BJ. So we have our favorite right angle triangle as usual. And of course, see your color code. You know what is adjacent, what is opposite, what is hypotenuse, based on the information that you have in color. The known side is opposite to the given angle. The known side is this one, and it's opposite to this given angle. Right? And which one are we going to be finding first? We're going to be finding BK first. So this is the hypotenuse. So opposite and hypotenuse, we know that is sine. And of course, the hypotenuse is in the denominator. So when it is in the denominator, we put that on the right-hand side. We transpose by multiplying the BK on the left-hand side. And of course, BK is multiplied by sine 60 here. So we're going to divide by sine 60. We're going to be dividing by sine 60 on the right-hand side. And that is what we have right there. So sine 60 is 0.866. And we're going to divide 25 by 0.866. So BK is 29 kilometers. Having two sides of a right angle triangle, we may use Pythagoras Theorem to find the other. However, we do not have to use a calculated value, so we do not. So we're not going to be using a previously calculated value. We just go straight ahead and use the information that we had before. So if we're going to be finding BJ now, that BJ is adjacent, and the side that we have is opposite. So opposite and adjacent, what trig ratio? Tan. So tan 60 is equal to 25 over BJ. So BJ, of course, when we multiply on this side, because dividing on the right-hand side, we multiply on the left-hand side. We get BJ tan 60 is equal to 25. And of course, BJ is multiplied by tan 60 right here. So we are going to divide by tan 60, which is by 1.73. And this is our final answer. The known side is opposite to the given angle, and the side that we are attempting to find is adjacent to the angle. The tan ratio is therefore appropriate. So opposite and adjacent, we use tan. A man swims 100 meters from a buoy on a bearing of 150 degrees. He then swims 150 meters on a bearing of 020 degrees. How far is he from the buoy? And what is his bearing from the buoy? So what are we going to do first? Let's see. Show the direction 150 degrees clockwise from north. The man swims 100 meters from a buoy on a bearing of 150 degrees. So we are going to take our north at A, and we are going to show that the angle is 150 degrees in a clockwise direction beginning at north, and that we have our 150 degrees going clockwise in a clockwise direction from north. Now, after swimming all the way down here, his direction changes and another bearing is given. Because another bearing is given, then we have to set up another north line and we have to do the same. Take our bearing from north in a clockwise direction. So, there you have B, there you have the north line, and there you have your bearing of 20 degrees. So it's going from north in a clockwise direction. Right. And that distance is 150 meters. Of course, what do we say next? Complete the triangle. There is no trigonometry without triangle. So we need to complete the triangle by doing that. Good. And let's see if we can answer the question. We need to find AC, the distance from the boy at A to the man's final distance. So we need to find AC, and that is the distance from the boy, which is at A, to the man's final destination. We have two sides of the triangle. We need at least one angle. Now, as far as we have here, this 150 degrees, not in the triangle, so it cannot be used directly. This angle here, no information there. This one here, this part over here is 20 degrees. We do not know what over there is. So we cannot use it either. So we have to go on this foggy road in order to find this angle in order that we may be able to continue. So let's see what this statement says here. We need at least one angle. The only angle internal to the triangle is a part of the angle at B. So there's only one angle is internal to the triangle, and it's just a part of the angle, it's not the entire angle. We may take this as a hint that we may be able to find the entire angle at B. So we can take it as a hint that we can find the other part of the angle here, and hence the entire angle at B. So how do we do that? Let us flip the page. In finding the entire angle at B, we need to call on our general knowledge of geometry. Extend the north line at A downwards. This will give angles on a straight line. Lovely. So what do we know then? If this is 150 degrees and this is a straight line that we have here, then we know that this is the rest of 180. Angles on a straight line had to give 180. So we know that this part is 180 minus 150, which is 30 degrees. Right there. Alternate, which is Z angles, are equal. The remaining portion of the angle at B is therefore 30 degrees. So based on the Z, let us put that in. See? Let's go again. So that is your Z. And your alternate angle, so your 30 degrees is going to be right there. You want to take a good look at it again? Right, so here's your Z. Right, so this is also 30 degrees. This is your Z, so this is also 30 degrees. This part is 30 and this part is 20, and our problem is solved. The entire angle is therefore 50 degrees. Having two sides of a triangle and the angle that they form, we may proceed to use the cosine rule in order to determine the side opposite to the angle, which is AC. Do not forget your cosine rule. Your cosine rule says that if you are going to find a side of a triangle, you need the side that is opposite, you need the angle that is opposite to that side. And you need the two sides that the angle form. So you know that you're going to use this with the angle. Remember that the cosine rule, as we said before, is defined on a vertex of a triangle. Vertex meaning the angle that is there and the sides that form the angle. So now let us find AC. Do not forget that the cosine rule is defined on the vertex of the triangle to the extent that if we need to find AC, then that is found by saying AC squared is equal to this squared plus this squared minus 2 times this multiplied by this cosine of the angle that we have right there. So no problem seeing this. I think that we have gone through this cosine rule and this particular application so many times that we should have no alarm whatsoever. And of course, that's just a matter of simplifying by squaring and of course multiplying these numbers right there. Then we are going to be multiplying by 0.64 right there, and at the same time adding these two. So finally we'll subtract this, and AC is equal to that. AC squared, so we need to find the square root of that. That gives 115 meters. So 115 meters, that's the value of AC. We have a little bit of mental gymnastics left, and that is finding the bearing of the man at C from the boy at A. The angle that we need is the one that goes clockwise from north. So we are going to go clockwise from the north line at A to the line AC. So this is AC, so we need to go clockwise from north and go right there. So the angle that we want is from A, the bearing is from A, in a clockwise direction, goes right there, and stops at the line that goes from A to C, because we are finding the bearing of C from A. That's it, right there indicated. The angle is not inside the triangle and may not be found immediately. After finding the associated angle, that is the internal angle, it may then be found. So we may not find this bearing angle as yet. We know that the entire thing is 150 degrees, and we need to find this one, but we cannot do that directly. We have to find this one first. So let us flip the page and see what happens. The angle is surely less than 90 degrees. We may use the sine rule to find it. How do we know that it is less than 90 degrees? Well, it might well be an intellectual estimation. Well, that gives us the idea that it has to be less than 90 degrees. However, it has to be less than 90 degrees, so we are safe using the sine rule. And what is the sine rule? Remember that in order to apply the sine rule, we need a side of triangle and the angle opposite to it. So we need side and angle opposite to each other. And of course, if we are going to find an angle, we need the side that is opposite to that angle also. So in our equation, we have only one unknown. So we need a side and an angle opposite to each other. Yes, we have the 50 and the 115. Those are opposite to each other. The angle that we need to find is this one that is marked in blue. That is opposite to this one that is in blue. That is the angle that we need to find. And of course, we have the side that is opposite to it. So when we say sine A, for argument's sake, sine A over A, sine B over B, we are going to have this two knowns, and then we are going to say use these two, and this one is going to be the only unknown. So let us continue. So sine A over 150, this is the angle that we are going to be using, and we are calling it A. Sine A over 150 is equal to sine 50 over 115. And please don't let us have to labor too much working out this problem that has the sine rule. Just transpose this 150 to the other side. It's divided here, multiplied on the other side. We need to find sine 50, 0.766, that we use right there. And of course, we do our algebra, and we get sine A is equal to 0.999. So when we do sine inverse of that, we get 88 degrees. So it can be seen that the entire large angle is 150 degrees. The internal angle is 88 degrees. The bearing is the one that comes down from north to the line AC. So this is the bearing, 150 degrees, that comes down right there. The angle that we need is the one that is here. The one that we have is right there. So if we need to find this angle, we are going to take the 150 and subtract this one. So the bearing is equal to 150 degrees minus 88 degrees, which is equal to 062 degrees. There's a reason why we are writing that with a 0 in front. Why? Do not forget that a bearing must be expressed by using 3 digits.